Welcome back, chemistry fans. Today, we are going to deal with reaction rates. And so we're going to see what happens when you change the concentration, what happens to the speed of the reaction. And then we're going to take that and make that into a graph on a Google Sheet. All right, so let's get started. Let me share with you my other camera, and we'll get going. Okay, so what you see in front of me on the desktop here are the 5 glasses that we're going to use for the 5 different concentrations. You see a table that has a bunch of X's on it, and we would be placing those 5 cups onto the X's, and we're going to watch as the X's disappear once the reaction occurs, but they're going to happen at different rates, so we have to set a stopwatch or use your phone to try and time this scenario. So I will get my phone up and running here so that we have a stopwatch and we will be able to time once we get ready. But we got to first pour in our chemicals to get this started. So we're going to take our starting material. This is sodium thiosulfate. So we're going to take 50 milliliters of sodium thiosulfate. We're going to put that in the first one. So we'll just go in order. So I've got 50 in the first, and then I'm going to put 40 into the second. And they don't have to be exact. They can be pretty close. Don't overfill it, but we certainly want to keep it pretty close. And then it's going to go down to 30, and then we'll have 20 and 10. So keep getting this lower and lower and lower amounts, concentrations, 20, and finally the 10. All right, so we've got all of our amounts correct on there of our sodium thiosulfate in order from 1 to 5. And then next, what we're going to do is we're going to add water in a reduced amount. So we'll put 0, we'll put 10, 20, 30, and 40, so that all of these end up having all of them end up having 50 milliliters of water. Okay, so the first one, we don't put any water into. The second one, we're going to put 10 milliliters of water. So let's see where we are at 10, close. There's 10. So now this one should have the exact same amount of water of total solutions. They both should have 50 milliliters. And then the next one goes up, it will have 20 milliliters. So now this has 50 milliliters of a solution, and then we'll have 30 milliliters, just regular old water. Now this one has 50 milliliters, and then we will put 40 milliliters in the final one. We don't ever use 50 milliliters of water because that would have no reaction if you don't put any chemicals in it. Okay, so we have all of these ready to go. Now I'm going to move my camera so that we can start seeing the reactions take place. So I'm going to try and hold the camera up above. Unfortunately, my other camera is not working right now, so we're not going to be able to have a overhead vision that I had originally designed. Okay, so I have prepared 5 milliliters of 2 molar HCl, that's an acid, and it's going to react with the sodium thiosulfate, and it's going to create a colloid of sulfur, and that's just going to be floating around, and it's going to become solid, and it will then try to settle, and as it does, it will stop allowing you to see the view. So I'm going to switch my cameras right now so that we can see what I am talking about. So now what you're going to see is an overhead view of the first container. And in the view of this first container, I'm going to keep my stopwatch in here so that you can see how we're doing it. So here's my acid. As soon as I pour it in, I'm going to start my camera time. So boom, I start it, and I am now going to insert it in, pour it in. So now my acid is in there, and we are waiting for a point where we can no longer see the X in the bottom of the container. And it will be a slow process, but it will eventually occur. And so now you're starting to see that it's obscuring. And once we can no longer see that X, we are going to stop the watch. And that is right there. So it took us about 27 seconds. So that is what we are going to enter into our data table. So I have created a data table over here, and I've got in my first concentration, I've got 27 seconds. So now we're going to continue the exact same process for each of the final materials. And so what you'll notice over here, first off, you'll notice there's a horrible stink on it, but you notice how you can no longer see that X at all. It's whenever we first see it. So we're going to do this for each of the same materials, and we're going to time it. So let me get 5 more milliliters of acid, and we'll do the same exact process. Okay, so we're ready. I have cleared out my timer, and I have poured up 5 milliliters again. So this time I'm going to dump it in a second container with less concentration, and I will start my timer. So I pour it in and I start my timer. So my timer is running, and we will observe to see how long it takes for this reaction to occur. We know we won't have any kind of reaction until at least 27 seconds, where it completely obscures the vision. So it's starting to obscure it. I could still see the X. I can still see the X. And so I could still see it's a little bit beyond it. So now we're going to stop it right there at 30. And I'm going to go over to my screen now, and I'm going to see that that one went to 30. All right, next we will get our next data point. So let's go and switch our cameras, and let's now do the exact same process. So I have measured out my 5 milliliters, and I have zeroed out my stopwatch. So I'm going to pour in my 5 milliliters for a third time. I'm going to start my stopwatch. And we will watch, and then hopefully we'll see that this one goes a little bit longer than 30 seconds before we can no longer see that X. And we are at now about 20 seconds, and you start to see the reaction occur. It's a little slower. I could still see the X. I can still see the X. I could still see the X. So this one definitely was slower. I can no longer see the X, so I'm stopping it at 40 seconds. So now what I'm going to do is I am going to go over to my chart, and I'm going to put in 40 seconds. Boom. 40 seconds. All right. So now we're going to go to the third, or the fourth rather. And so let me get my 5 milliliters ready. Okay, here we go. I've got my 5 milliliters ready, and I'm on my fourth container. So I'm going to pour it in, and I'm going to start my stopwatch. So I am ready to go. And hopefully this one's going to take a little bit longer than 40 seconds. What a nice, we should have elapsed speed to make this happen faster. And maybe that's what I'll do on the last one, because it's probably going to take closer to a minute. We are already at 30 seconds, and we're not seeing a whole lot of evidence of what could be here. So now it's starting to change. Now I'm starting to see some of that yellow color in here. It's very slow, but it is starting. And we are at 47 seconds already. I can still see it. I can still see it. It is very, very slow. I can still see the X. At this point, I will say that I can no longer see it, and we're at 1 minute 8 seconds. So we'll just round that up to a minute. Yeah, we'll just keep it at 68 seconds. All right, so let me share my screen. put that in at 68. We can't put it in as a minute 8 because the computer doesn't understand that because it's numbers. So we're going to put this in at 68. All right, I'm going to do one more experiment with this one. Since that took so long, I'm going to do a time elapsed on this one. Okay, we are at 1 minute on the timer for this final one. And even at this, man, it is super, super slow. So we're already equivalent to what was the last one. And it is taking it a while. It is now starting to show the reaction. So we're going to count this until it's completely obscured. And then we can get our final data point that we can make a nice rate of reaction graph. First order rate of reaction graph. So here we go. It is starting to get darker, or it's starting to get obscured. We are at 1:40. It's slow. So I'm glad that we at least fast forwarded a little bit for you so that you can see the process and not so painfully so. All right. We're at 1:50. So it's going to take over 2 minutes for this to finally occur. I can still see the X. I can still see the X. It is not fully obscured yet. And we are at 2:10. So I could still see the X. At this point, I'm going to call it. Now I can probably no longer see the outline of the X. So that is 2:27. All right, so let me share my screen. And we are going to put that in there, 2:27. That is 120 plus 27. That's 147 seconds. All right, so now I have my graph. Let's go ahead and highlight not only the numbers, but the labels as well. And then come over here and we will push the button that gets us a graph that it's this icon right here, insert a chart. And what we hope to see is that, yes, absolutely, the data supports this completely. We can change this into a nice curve. And that is exactly what we hope your data will look like, that the rate changes as the concentration changes. All right, this is everything that I wanted to show with you. Thank you very much. We'll talk with you again soon. Bye-bye.